Hello students, welcome to Sir classes. For detailed information about our classes, you can visit our website, that is www.sauravsirclasses.com, and for other queries and doubts, you can just call us or WhatsApp us at this number 9836793076. You can even like our videos and subscribe our channel for more videos. Today we are solving some questions on kinematics, and here our first question is: a boat which has a speed of 5 km per hour, the speed of the boat is given, that is 5 km per hour, in still water crosses a river of width 1 km along the shortest possible path in 15 minutes. The velocity of the river water in km per hour is, and here 4 options are given, and those are option A, that is 1, option B, that is 3, option B, that is 3, option C is 4, and option D, that is root 41. So now shortest possible path comes when absolute velocity, when the absolute velocity of the boatman comes perpendicular to the river current. Velocity of the boatman comes perpendicular to the river current. Now I'll show the diagram. Okay, so let me draw it, and that is, let us assume VR, that is velocity of the river, and the perpendicular, that is velocity of the boatman, and here is the VBR. This is the river current. Now we know that T, that is time, is equals to omega divided by VB, that is velocity of the boatman, that is, we can write it as omega divided by root over VBR square minus VR square, because from this diagram we can write it as, if this is 90 degree, we can write it as VB square plus VR square is equals to VBR square. So from this we can write that VB is equals to root over VBR square minus VR square, and putting the value we can write it as 1 by 4 is equals to 1 by root over 25, as VBR was 25, so it is 25 minus VR square. And from this we can get the value of VR, that is velocity of the river, that is 3 km per hour. So here option B, that was given as 3, is our correct answer. Now here's our next question, and it's a bit tough and it's very much interesting. I swear you guys will have fun while doing this. Now the question is: the trajectory of a projectile in a vertical plane is y is equals to ax minus bx square, where a, b are constant, a and b are constant, and x and y are respectively the horizontal and vertical distance from the projectile from the point of projection. The maximum height attained is, we have to fill this dash, and the angle of projection from the horizontal is, we have to find these two values. So now let's proceed to the solution. It is given that y is equals to ax minus bx square. So for height that is y, if we have to get the maximum value of y to be maximum dy dx must be 0. Therefore this is a minus 2bx. So from this we can get the value of x, that is a by 2b. So for the first dash, that is a, y max, that is the maximum value of y, is the maximum height, is the maximum height. Here h is equals to a into a by 2b minus b into a by 2b square. This is equals to a square by 4b. So we can write the value here, a square divided by 4b. Now for the second dash that was asked, the angle of projection from the horizontal, we have to put the value of x is equals to 0 at dy dx. At dy dx, x is equals to 0, that is a is equals to tan theta 0, where theta 0 is the angle of projection, where theta 0 is the angle of projection. So here we can write it as theta 0 is equals to tan inverse a. So here the angle of projection is tan inverse a, and this is our answer.